Hey everybody, this is Mr. Backstrom, and today I want to take a look at an example of one of the exercises from 2-1. This is just like number 19, and what it says is the expression, and it gives us this crazy looking thing. It says f of x plus h minus f of x over h for h not equal to 0. They have to put that because since we have the h in the denominator, we can't have a 0 in the denominator. And this thing is called the difference quotient, and if you end up taking calculus, you'll be using this quite often when you talk about limits. But for now, we want to find and simplify the difference quotient for the following function. So they define this function as 2x squared plus 2x plus 10. And as we talked about in class, uh, every time we have f of something other than just an x, what we do is we take this function here and we just replace the x with whatever's in this parentheses. So for this one, wherever there's an x, we're going to replace the x with an x plus h. For this one, it's just going to be the same as this function here. We just have to remember to distribute that negative, and then that'll just remain in h. So down here, what I'm going to do for the x plus h, and I'll put this whole first thing in parentheses there. So the f of x plus h, I'm just going to write this whole function down, but wherever there is an x, I'm going to replace it with an x plus h. So this is going to be 2. Instead of an x, I'm going to put x plus h, because this is what this tells me to do, squared, and then plus 2. Once again, there's an x there, so that tells me to replace it with an x plus h, and plus 10. All right, that takes care of this first term here, and then I have a minus. I'm going to remember to put a parentheses around this because I want to remember to distribute the minus sign there. And this is just f of x, so that's just the function just like it is. So that's 2x squared plus 2x plus 10. All right. Okay. So this takes care of the f of x right there, and then this is all over h. All over h. So this is quite a mouthful there. That's a lot of things to keep track of. And now we basically have to do some distribution. We've got to do some foiling. We got to combine like terms. We're going to end up canceling some stuff out, and then we got to reduce it as far as we can. So let's go ahead and just start working this. So let's see what this x plus h squared thing is. I'm going to do this over to the side just because I want to see what that looks like. So, because, and remember, I do exponents before I do the multiplication of that too because of PEMDAS, right? The parentheses, exponents, multiplication, division. So exponents come before multiplication. So let's see what x plus h squared looks like. So that's just going to be x plus h times x plus h. So when we FOIL that, it's going to be the first terms, x squared, plus the middle term, so h times x, plus the outer terms, plus h times x, plus the last terms, plus h squared, and we can combine the inner and the outer terms, so this becomes x squared plus 2hx, or xh, doesn't matter, multiplication is commutative, plus h squared. So this is what this FOIL comes out to. So I'm going to have the 2 there, and then this FOILed thing comes out to x squared, which I worked off to the side, plus 2hx plus h squared. All right, plus I'm going to distribute this. So the 2 in the x and the 2 in the h, so plus 2x plus 2h plus 10. And now I'm going to distribute this minus sign with all of these terms, which are just take the opposite sign of all those. So minus 2x squared minus 2x minus 10. This is all going to be over that h. So once again, a lot of things to keep track of. So now I have a minus 10 and a plus 10. So I can cancel those out. And I also have a minus 2x and I have a plus 2x. So I can cancel those out too, so I don't have to deal with them. Now I'm going to distribute this 2 amongst these three terms. So let's go ahead and, so this is going to be 2x squared. 2 times that is plus 4hx plus 2h squared plus 2h, make that a little bit better, minus 2x squared are all over h. All right, let's see if there's anything else we can cancel out. Oh, look, I have a positive 2x squared and I have a negative 2x squared. This right here is an h. I don't think I drew that too well, so let me go ahead and make that a little bit better there if I can. All right. And doesn't look like anything else is going to cancel out, but I can factor an h out at the top. So I'm going to pull an h out because there's an h in each one of those terms. Once again, I messed that h up. I'm not good at drawing h's. So if I pull an h out, then I can just write everything else without the h. So that gives me 4x plus, I pulled one of those two h's out, so that's just leaves me with one h left, plus 2 all over h. And now I have a h on the bottom and an h on the top I can factor out. And then my final answer should be 4x plus 2h plus 2. And that's about as far as we can go with it. There's nothing else that cancels out, and we're done. So that is a pretty crazy problem. So, you know, go through this a couple of times, try it maybe with a couple of different functions, and I'll give you one little hint. At the end, you should always be able to factor an h out, and those h's should always cancel out from the bottom and one from the top. All right. If you have any questions, let me know, and I hope you have a great rest of your week. Thank you.